Okay, example 4 from 14.5 is about an icicle. I know we don't know what those are in Phoenix here, but it says here, a cone-shaped icicle is dripping from the roof. The radius of the icicle is decreasing at a rate of 0.2 centimeters per hour, while the length is increasing at a rate of 0.8 centimeters per hour. If the icicle is currently 4 centimeters in radius and 20 centimeters long, is the volume of the icicle increasing or decreasing, and at what rate? Okay, lots of things are changing. If that icicle is dripping, the radius is going to change, the length is going to change, and the volume is also going to change. So we've got a lot of things going on. So let's list our givens. We've got a radius, we've got a height, we've got a rate at which the radius is changing. I'm going to call that dr dt. We have the rate at which the height of the icicle is changing, dh dt. And then we have a rate at which the volume of that icicle is going to change, dv dt. See if you can fill in as many of those givens as possible. So reading back through the example, I saw that the radius at that moment we're talking about is 4 centimeters. I also saw that the height of the icicle at the exact moment we're talking about is 20 centimeters. It also says in the question that the radius of the icicle is decreasing at a rate of 0.2 centimeters per hour. Now it's important that you label this correctly. Did you say 0.2 centimeters per hour? But be careful. Did you say negative 0.2 centimeters per hour? Because it's decreasing, and so we have to represent that mathematically with a negative so that we know that it's decreasing and the radius is not actually increasing. Okay? All right. What else does it say? It says while the length of the icicle is increasing, so that's when we're going to have our positive 0.8 centimeters per hour. It's asking us to find the rate at which the volume is changing and if it's getting bigger or smaller, right? And so dv dt is what we're actually trying to find. So first step is to list all of your givens. Remember, our next step is to find a formula or an equation that relates all of this stuff together. So is there a formula or equation that we might know that talks about radius, heights, and volumes? Oh, well, there happens to be a formula for the volume of a cone. The volume of a cone is 1/3 pi r squared h. Now, you should know some of the basic formulas for area, like area of a circle, area of a rectangle, area of a triangle. But if it's something like surface area or volume of a three-dimensional, I would probably give you this formula on the test. But it is 1/3 pi r squared h. And now we have to, step number 3, is find the rate at which all this stuff is changing over time. We need to find the derivative. So pause the video and see if you can find the derivative correctly. Okay, be careful. Let me change into maybe a green. All right, I have the rate at which the volume is changing, dv dt. I saw here that I have a 1/3 pi, and 1/3 pi is just a number, so I left that number chilling out in front. But then I had an r squared times an h. Now be careful, how many of you just tried to take the derivative of r squared and the derivative of h and slap them together? Be careful, that's a product rule, right? I have an r squared times an h. The only way that I can find the derivative properly is using product rule. So I have the first times the derivative of the second. The derivative of h is 1 dh dt, plus the second times the derivative of the first. The derivative of r squared is 2r dr dt. It's important that you take the derivative correctly, or else the rest of it gets messed up. All right, now that I have all of that information, hopefully we have all the variables that we need. We're going to plug in all of our givens, and let's see if we can figure out what dv dt is, the rate at which the volume changes. All right, let's do this for now. Okay, so I plugged in my r, I plugged in my dh dt, I plugged in my h, my r, and my dr dt, making sure, remember, that I have that dr dt as negative. I then used my calculator to calculate what this was, and I ended up getting negative 20.106. Let's talk a little bit more about what it means, though. Remember that we're finding dv dt, and dv dt means the rate at which the volume is changing. If I ended up getting a negative number, what does that mean about the rate at which the volume is changing? Is it increasing or decreasing? Yeah, it's decreasing, right? So that means as this cone drips, it's going to lose volume. The volume is going to decrease at a rate of 20.106. Ooh, we got to figure out what the units are, right? So again, when you're plugging in your values up above, it might be helpful for you to actually plug in the units too. When I plugged in this 4 for my radius, and then I squared it, my radius was 4 centimeters. So then when I went and squared it, I now have centimeters squared. I then multiplied it by a 0.8 centimeters per hour. So if I have centimeters squared times centimeters per hour, don't I have centimeters cubed per hour? And it should make sense because volume is normally in units cubed, and if it's a rate, it's unit cubed per hour. So give me a sentence. Give me a sentence with the 3 things. When is it happening? What's happening? And what is your answer with correct units? I wrote here, when the radius is 4 and the height is 20, and I should probably put some labels on here. When the radius is 4 centimeters and the height is 20 centimeters, the volume is decreasing by 20.106 centimeters cubed per hour. Okay. I'm going to go ahead and stop the video. I'd rather you have a bunch of different small videos for each example. I'll do example number 5 in the next one. Okay, guys? Hope you're doing okay.